bottom of A12, second half of Appendix B. All right, we're going to start off with the several different forms of a line that we work with. Now, I know we've been doing this since Algebra 1, and we're very proficient with this material, so we're going to go through it relatively quickly because of that. However, we do want to clear out some of those summer cobwebs, so we do want to go back through it. So remember that if you have an equation that is in standard form or general form, it means the same thing, then you're going to have everything over on the left-hand side set equal to 0. A, B, and C are integers. We talked about that Friday, that means positive and negative whole numbers, so no fractions, no decimals. A and B cannot both be 0 at the same time because then you wouldn't have an X or a Y term, so you would have something like 5 equals 5 or 5 equals 0, neither of which is going to graph as a line. Here is our point-slope form. It's called that because you need a point and a slope. And our slope-intercept form, remember that our M is our slope and our B is our y-intercept. So for example 3, it says find the equation of the line that goes through the point 1, -7 and has a slope of -1/2. So two different ways we talked last year about how to do this. I don't care which way you do it. Because I have a point and a slope, I might want to use my point-slope form. So if I'm using point-slope form, I'm going to go through and say y minus y1, my y value was -7, is equal to m. M was -1/2 times x minus x1. x1 was 1. Now, if I said minus a negative is plus and I left that y plus 7, that would be point-slope form. They asked me to put this in standard form. So to put it in standard form, I'm going to need to do some simplifying. I'm going to distribute that -1/2 all the way through. So -1/2 times x is -1/2 x, and -1/2 times -1 is going to give me a positive 1/2. Now, I need to combine the positive 1/2 I got over here with the positive 7 I had over here. So if I subtract that 7 over, if I had a positive 1/2 and then I subtracted 7, that's where we're getting that -13/2. And if by chance they asked me to put this in slope-intercept form, that's slope-intercept form. My slope is -1/2, my y-intercept is -13/2. But they wanted it in standard form. So in standard form, we're going to move it all over to the left-hand side, set equal to 0. So I'm going to add that 1/2 x over, and I'm going to add that 13/2 over. In standard form, A, B, and C have to be integers, so I cannot have those fractions in there. So to clear out my fractions, I'll multiply everything by the least common denominator, which was 2. So we multiply this whole thing by 2, and that's where we get the x plus 2y plus 13 equals 0. That would be our standard form. Now, last year we mentioned a totally different way of doing that problem that you might like a little bit better, particularly if you're trying to put your answer in standard form. In this case, we're going to use the idea that slope is equal to the opposite of a over b. Where does that come from? Well, if in calculus our goal is to kind of understand the reasonings behind things and why they work the way they do, if I had something in standard form, you don't have to write this down, but if I had something in standard form and I took standard form of the equation and I switched it to slope-intercept form. Slope-intercept form, I got y by itself on the left-hand side, right? So I would subtract the ax to the other side, and I would subtract the c to the other side, and then I would have to divide through by that b. Once I do that, this is what I would be left with, and if you'll notice, if you match that up with a slope-intercept form, my slope is the opposite of a over b, and my y-intercept is the opposite of c over b. So that's what's giving us the right to use the definition of slope as the opposite of a over b. So if we were told our slope was -1/2 and we just showed how slope is the opposite of a over b, if you match those two up, you can see how 1 is in the place of a and 2 is in the place of b. So if I put 1 in the place of that a and I put 2 in the place of that b, look how close I am to my final answer, and I'm in my first step. So all I would have to do is just find c and I'd be finished. That's where the point comes in. We've already used the slope, but we haven't used the point. So if I know that I have the point 1, -7, I could put 1 in for x, and negative 7 for y. You could do that in your head, most of you, and not even have to write it down. But if I put 1 in for x and negative 7 in for y, I'll get 1 minus 14, which is negative 13, plus c is equal to 0. So that means c would have to be 13. So bring that 13 up and throw it in the place of c, and look what you've got. 1x plus 2y plus 13 equals 0. The exact same equation we got over here. So two completely different ways to do that problem. I don't care which way you do it, whichever one you like better. So let's look at another one. Example number 4. For example 4, this time they give me 2 points. So what do I need to create the equation? What do I need? A slope, right. So how do I get the slope from 2 points? Formula from Friday? Perfect. y2 minus y1 over x2 minus x1. So we could go through and say negative 4 minus 2 and 3 minus negative 1. And I'll have my slope. Now, I have a point and a slope. I have everything that I need. And they asked me to put this in standard form. So you can go back to either of these two methods that we just talked about. I don't care which way you go. I'm going to do a second example of this opposite of A over B guy. Because when they asked me to put it in standard form, that's just such a fast, easy way to get there. All right? So what would my A be? 3. What would my B value be? All right, so let's put 3 in for A and 2 in for B. Then how am I going to find C? Put in one of the points. I'm going to choose 1 and 2 because that to me seems easier than 3 and 4. So I'm going to use negative 1, 2. So I'll put negative 1 in for x and 2 in for y. So that would give me negative 3 plus 4, which is a positive 1. So if 1 plus c is equal to 0, then c would be negative 1. I can put that back there, and there's my equation. 3x plus 2y minus 1 is equal to 0 in standard form. All right, example number 5, they talk to us about linear equations. If you have x raised to the first and y raised to the first, or either one of those, you can have like y equals 5 or x equals 6, something like that, where you just have an x or a y. But if you have x to the first and y to the first, you're going to have a linear equation. It's going to graph as a line. How many points do you need to create the equation or to create the graph of a line? 2. So that's why it's important to find out that it's linear. That lets me know I only need to plot 2 points as opposed to, maybe plotting 10 points. So if I'm going to plot 2 points, to me, the two easiest points to graph are the x and the y-intercept. Your x-intercept, remember, is when your y value is equal to 0, and that's where your graph crosses the x-axis or intersects the x-axis. Your y-intercept is just where x is equal to 0, and that's where your graph crosses or intersects the y-axis. So the reason I like those 2 points so well is that you really can do it in your head. It's like you put your finger over top of this 3x right here, because you put 0 in for x, that piece goes away. So if you put your finger on top of that, you're just left with negative 5y is equal to 15. You can divide that out in your head and get y is equal to what? Negative 3. Then I'm going to do the x-intercept. So I'm going to put 0 in for x. So it's like, I'm putting 0 in for y. So it's like I put my finger over this piece of the graph, and I'm just left with 3x equals 15. So what's x? 5. Now, I always plot a third point. You don't have to, but I do just to make sure that they're collinear, that they're actually making a line, and that I haven't made a careless mistake, and that I have a triangle, and that I need to go back and reevaluate my points. So I do 3, but you can get away with doing 2. So there's the graph of our line. Now, when we talk about lines, lines are straight, direct paths. It's the shortest distance between 2 points, right? So when I think about lines and I think about straight paths, it reminds me of one of my all-time favorite verses, and that's Proverbs 3, 5, and 6. It says, if you'll just trust in the Lord with all your heart, don't lean on your own understanding. You can trust Him and trust His understanding of the situation, even when it doesn't make sense to you. All that you have to do is in all of your ways acknowledge Him, put Him first, And he promises that he will make your path straight, lay it out right in front of you. You have huge decisions to make this year. You got to figure out what college you're going to, and you're starting to think about what major am I going to look at, and what am I going to do with the rest of my life, and who am I going to marry, and where am I going to live, and oh my word, it can just be daunting to think about life-changing decisions that you have to get it right. You can't be wrong with those. How am I supposed to figure that out? How am I supposed to know that? God says that if you just trust him and put him first, he will lay it straight out in front of you. It's a promise. So just an encouragement when you are drawing your lines that you can count on that promise from God for this school year, for your future. All right, so let's say that instead of graphing an equality, 3x minus 5y equals 15, what if we wanted 3x minus 5y is less than 15? Remember, linear inequalities very similar. With the linear inequality, I'm going to graph it just as if it said equal to, but if it's less than or greater than, I'm going to put a dotted line, and if it's less than equal to or greater than equal to, I'm going to put a solid line. So what would we put for this one? Dotted or solid? Dotted, yeah. So it's the exact same x-intercepts we had a second ago, the exact same graph we had a second ago, only it's dotted instead of solid. Now, when you have an inequality, it is going to cut your Cartesian plane into two half planes. And one of those half planes will be a solution. Every single point on half of that plane will work in that inequality, and every single point on the other half of that plane will not work in that inequality. So we said the easiest thing that you could do is just to pick a point and test it. If it works, every single point on that side will work, and you can shade that whole side. If it doesn't work, then you know you're not supposed to shade that side, you're supposed to shade the other side. Well, every year I have students that go, I don't really have to do that whole test point thing, because I can just look at this less than right there, and that tells me to shade below. Okay, well, let's test that hypothesis. I'm going to pick a test point that is not on my line to determine which side to shade. So I pick 0, 0, because that's an easy point to plug in, right? So if I put in 0, 0, I'm going to get 0 minus 0 is less than 15, or 0 is less than 15. Is that true? Yeah, the last time I checked. So if 0 is less than 15, if that point worked, that lets me know that I should shade every single point on that side. That was not below, that was above. Okay, well, how come sometimes that little trick works and sometimes it doesn't? If you want to use that little trick where you look at this sign and that sign determines whether you shade above or below, you must solve your inequality for y first. That is the only time that little trick works. And that also helps us understand why it didn't work the last time. Because if I were to solve that inequality for y, I would subtract the 3x from both sides, and then I would divide by a negative 5. What happens when you divide by a negative? You have to reverse the inequality sign, right? And so that's why it misled me. And that's why I can only look at it in this form. Yes, then that would tell me accurately to shade above. Now, we can also do these on our calculator. And of course, to do it in my calculator, I'm going to have solved it for y as well. Two different ways that we can do this on our graphing calculator, depending on whether we have the inequalities app or not. You can go into normal y equals and type this in. So if I go into normal y equals and I type in 3/5 x minus 3, I'm going to have to tell my regular calculator how to graph this. So I would come over here and toggle until I got shade above. You have options of shade above. So I'm going to come on to y equals and type in my equation, and then I'm going to come over and toggle between my different settings. I can choose shade above, shade below, whatever I want. So I will have to tell my calculator to shade above. However, if I go into my applications and I turn on the inequalities application, when I hover over top of my equal sign with my cursor, I get these other options down here that I don't normally have. And I operate those by using those keys up at the top, the y equals window zoom. You can see how they line up. Since I wanted less than, or I'm sorry, if I wanted a greater than for this one, you can see that that lines up above trace. So I would hit my trace button. And you can see, you can also think of it as like the F4 there. So these are kind of like soft function keys. So I can choose greater than in that way. When I do that, my calculator sets this over here automatically. It knows to go shade above, and it also knows to go dotted for me. So I love that Inequalities app. Notice that the math print doesn't show up in the Inequalities app, so no matter what you do, you're not going to be able to type this as a fraction with the numerator on top and the denominator on bottom, and that kind of math print type that we've gotten very accustomed to. You lose those options when you're in that app. If by chance you had a system of inequalities where you had like two of these that you were working with, you would graph and shade the first one and graph and shade the second one, and your solution would just be your overlapping region. In your inequalities, there's not a way to write your answer out. Your graph with the shading is your solution. It is your answer. All right, the last thing we want to look at today is on page A14, and that's the idea of parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of each other. So, for instance, if your first slope was a positive 1/5, then your second slope would be the opposite of that, a negative, and the reciprocal of that, 5. So if your first slope was a -2, what would your perpendicular slope be? Right, positive 1/2. Okay, so example number 7, they tell me, create the equation of the line that goes through the point 5,2 and is parallel to the equation 4x plus 6y plus 5 is equal to 0. You have a point, what do you need? Yes, a slope. How can you get that? You're both right. You could take the equation and put it into slope-intercept form and get your slope that way, or you could use the opposite of A over B. Might be a little faster to do the opposite of A over B, so I'm going to go that way, but you could go either way you wanted. So looking at this, we've got AX plus BY plus C equals 0. So what's A? -4. What's B? Well, yeah, A was positive 4 and we had the negative. And then, right, B is 6. Now, you could reduce this to -2/3. I'm not going to because I want to point something out to you in just a second. So now I have a point and a slope, and I'm going to put that into my standard form. So over here in standard form, I'm going to plug in what's A? 4, and what's B? 6. All right, so you feel like you just ran in a big circle, right? Because you were looking at this and pulling out A and B, and then you were looking at A and B and plugging them back into the equation. Let me point something out to you. This is why I didn't reduce this. Do you see that you started with 4x plus 6y, and your new equation is going to start with 4x plus 6y? If A and B are the same, then the base of that equation is going to be the same, right? So you could skip this whole step of finding the slope. If you understand that, you would automatically know that this is going to start the same way, and all you have to do is find C. Okay, so how do we find C? Yeah, plug in 5, 2. So we're going to put 5 in for X and 2 in for Y and solve for C. And then we can put that -32 in the place of C in our equation, and there's our final answer. Now, if you had reduced this to -2/3, over here you would have gotten 2x plus 3y minus 16 equals 0. Those are equivalent equations. They graph the same way. One's just a multiple of the other, so no problem. All right, example 8, they give me 2 equations, and they ask me, are the graphs of those equations, are they parallel, perpendicular, or neither? So what am I going to use to determine that? Slopes, right. So looking at this first one, I'm going to do opposite of A over B. So what's A? 2, and what's B? 3, right? So slope would be -2/3. How about this guy? What's the slope going to be? Right, -6/4, then that would reduce to a positive 3/2. So are these parallel? No, because they're not the same. Are they perpendicular? Yes, because their slopes are negative reciprocals of each other. Perfect. All right, so here is your homework for tonight. On pages A15 to A16, we're doing 21 through 57, every other odd. Be sure you get the other in there. Omit 45. And then 35, 39, 55, 59, challenge 53. On numbers 21 through 35, be sure that you put those equations in standard form.